Hi students, question number 13. When a damped harmonic oscillator completes 100 oscillations, its amplitude is reduced to 1/3 of its initial value. What will be its amplitude when it completes 200 oscillations? Now, we have already studied what is meant by damped harmonic oscillation. When a simple pendulum or any system is oscillating in the presence of a medium, the external medium will exert an opposing force or resistive force that is called as damping. Because of that, the amplitude will be continuously decreasing, isn't it? So, initial amplitude will be continuously decreasing like this. And finally, it becomes 0. So that the amplitude versus time, if you draw a graph, means it is an exponential graph. And the formula and the concept, mathematical derivations of damped harmonic oscillations are not in the Tamil Nadu syllabus, but it is kept in the NEET and IIT syllabus, entrance exam syllabus. So it is better if you learn this expression. Okay, just like radioactive substance is decaying exponentially, the amplitude of oscillation will be decreasing exponentially, and that is given by A equal to A naught into e power minus k into t, where A naught is the initial amplitude. So initial amplitude is A naught. Okay, so this is initial amplitude A naught. So as the time progresses, the amplitude continuously decreases as per this equation. So A is the amplitude after a time t. Now what is given after it completes 100 oscillations, its amplitude is reduced to 1/3 of its initial value, is it not? So first I will write case 1. As per this problem, in case 1, I will take amplitude A1 is equal to A0 divided by 3. It is given 1/3 of its initial value. When means at a time t1. At a time t1 is equal to 100 periods. So one time taken to complete one oscillation is called period. So for 100 oscillations, the time taken is 100 times its period. Okay. In seconds I can write that. So now I am going to substitute in this equation. Okay. So A1 is equal to A0 into, okay, A0 into e to the power of minus k into t1 minus k into t1, that is 100 t. Now A1 is also equal to what? A0 by 3. So A0 by 3 is equal to A0 into e power minus 100 k into t. So 1 by 3, therefore 1 by 3 is equal to e power minus 100 into t. So this is our equation 1. This is for case 1. Okay, that is after 100 oscillations. Similarly, we have to find out what is A2 after 200 oscillations. So I will take this as case 2. So in this case, now A2, okay, A2 is equal to what we have to find out. And the time T2 is equal to 200 oscillations. So 200 periods, 200 periods you have to substitute. So I will write the equation A2 is equal to A0 into e power minus k into T2. So this is equal to A0 into e power minus 200 kt, because T2 is equal to 200 t, is it not? So k into 200 into t will become this much. So this also can be written as what? A0 into e to the power of, okay, e to the power of minus 100 kt the whole square. So this 200 kt can be written as 100 kt the whole square, exponential to the power. Okay, it is square value. But as per the first equation, in place of e power minus 100 t, Okay, so this is a e power minus 100 kt. So in place of e power minus 100 kt, what also shall be substituted is 1 by 3. So this is now equal to what? A naught into 1 by 3 the whole square. So this is equal to A naught into 1 by 9. Therefore, A2 divided by A naught is equal to 1 by 9. This is the expected answer. So after the completion of 200 oscillations, it will be, or this can also be written as what? A2 is equal to A naught divided by 9. Its oscillation will be 1/9 of the initial amplitude. So option D, 1 by 9 is the right answer. Therefore, option D is the correct answer. Okay, so this concept, though it is not in the Tamil Nadu State Board syllabus, sometimes this may be useful in solving in the IIT and NEET entrance examination. So this is very simple. Such equation will be studied by you in 12th standard in radioactivity also. So better you can do this problem and practice well. I hope you must have understood this well. Fine.